What up, everybody? Welcome to this video here. It's going to be the only video for this week because this week is going to be a little bit different. You do not need to actually turn in these notes. So if you don't really actually want to do all the notes, that's up to you. I'm not actually checking them this time because what I'm checking instead is the homework. The homework is going to be problems that are just like this. So I recommend doing these notes so that you can, actually understand what's going on and look back at them if you need to. And it's just good habit, getting good practice. It's the same exact regular stuff for school. But the actual thing you're turning in is going to be a homework assignment, which is going to be a bunch of practices of these problems. In addition, there's going to be, for lesson 2, there's just going to be a quiz. That's it. No extra material, no extra anything else. That door closed on its own. It scared the crap out of me. That's what I was looking over there all about. I don't know what's going on, but hey, whatever. Girlfriend's not laughing because she's asleep. I don't know what happened, but I guess she gave up on her homework and then went to bed. She's never asleep this early, so I don't know what's going on. She'll show up in 20 minutes, halfway through my video and annoy me. Anyways, here we go. So we have to do this homework. We have to get it done. And then after that, we're going to have a quiz, and the quiz is going to be just like the homework assignment. So just the one video for this week. Someone in that little survey that we did last week, they recommended that I write the written words down and then I read them off as a way to kind of focus on what I was doing. I think it was a good idea, so I'm going to try it. I didn't write down all the examples, just wrote the first one, and I'm going to go from here. I'm going to do the problem from here, and this is the written stuff. So this is kind of like my version of a compromise for it. So what are we doing today? We are going to be graphing polynomials. That's the title here, is graphing polynomials. And my essential question is, how can I graph a factored polynomial? If you'd like to write an objective, the objective that I would have written on the board would have said, I can graph a factored polynomial by first identifying the end behavior, zeros, and the respective multiplicities. So, yeah, I don't know what the deal is, what I'm saying. My brain just disappeared. I don't know what the deal is in my brain is what I'm about to say. End behavior, zeros, multiplicities. We did that on our video last week, and we're going to have to use all those facts to actually graph these things today. So if you notice, I've created a little cutesy little chart over here. There's going to be 3 distinct situations for our zeros and their multiplicities. And we're going to need to deal with that. And actually, I just noticed I screwed up. There's supposed to be a 3 on this. Okay. All right. Let's get going. So example number 1, f of x equals x plus 3, quantity squared, x minus 5, quantity cubed. We need to graph this factored polynomial. So I just said we're going to have 3 examples, and I just realized I want a 4th example. We're going to have 4 examples today. All right. So step 1, we need to find the end behavior. As a reminder, to find end behavior, we first need to find the leading term. So the leading term, just looking at it here, it looks like we're just going to have just a regular x out of this guy. We'll have an x squared out of this guy and an x cubed out of that guy. If we multiply all of them together, we end up getting x to the 6th. There's my leading term. So from last week, I'm not going to bring that chart back up. Someone else told me not to flip to the pages because that really made things confusing. So I'm just going to tell you that previous chart that we had last week, it kind of looked like this off to the side. It had a happy face over here. It had, this guy over here, and it corresponded to leading term and end behavior. The faster you can get this guy memorized, or at least just keep turning back to it, the easier your life is going to be. But this is a positive x to an even power. That was in our top left-hand corner. That means our end behavior is up on both sides. So we would say as x approaches infinity, f of x also approaches infinity, or as x approaches negative infinity, f of x also approaches negative infinity. So that's step 1, or positive infinity. Oh, I screwed that up. It goes up on both sides. That's the top left-hand corner. Okay. Anyways. So that's step 1, finding the end behavior. We also need to find the zeros and their multiplicities. This is just like last week. So our zeros, we have this guy right here. That's just going to be x equals 0. Over here, we have x equals negative 3. Over here, we have x equals 5. This one has a multiplicity of 1. This one has a multiplicity of 2. And this one has a multiplicity of 3 because of the 1, the 2, and the 3 up there. All right. So now that we have this information, here's how we use this information to actually help us graph this guy. So I'm going to go ahead and create my graph. Use a straight edge of some kind to create your graph. You don't actually need anything else. So we got this. Here is my graph going up. You do not need tick marks because we are only doing a rough sketch of the graph. You're going to see how rough the sketch is in just a moment. All I need is this, x, f of x, and a couple things here. So how you want to do this? Your first step on this problem is to mark down the zeros. Remember that zeros cross the x-axis. So we have x equals 0. That's going to be at the origin. So that's my first guy right there. We have x equals -3. So how about -3? You know, if you want to put tick marks, you can, but -3 will be somewhere over yonder. -3. Then we have x equals +5. That will be somewhere over here. Okay, so we have plotted our 3 zeros, our x-intercepts, our roots, our solutions. Now we need to plot the end behavior. So the end behavior, we have as x goes to infinity on the right-hand side, f of x goes to +infinity, because we're looking at this little chart over here, it goes up on both ends. What that really means is on both ends of the graph, we are going to be going up. So we should just kind of immediately draw in little arrows at the edges, knowing that we're going up on this graph. This is the setup to every single one of these problems. You're going to be plotting the zeros and plotting the end behavior. Basically, the arrow either goes here or it goes here, and the arrow either goes here or it goes here, because x is going left or right, and it's either going up on both sides, down on both sides, down on one, up on the other. You need to figure it out. And once you have this, the rest of the problem is pure logic. Let's look at how that logic works. Basically, this guy right here has to connect. We have to get to this next 0 here. But what do I do at that 0? What is going to happen over here? That's what this little chart's all about. And that's why we wrote down the multiplicities. There are 3 distinct possibilities for multiplicities. The first one we're going to do, I'm going to talk about, is an even multiplicity. That's what it's going to be what this guy up here is about, an even multiplicity. If you have an even multiplicity and you hit your 0, it is going to be a bounce. So it's going to, in other words, what I'm talking about is it's going to be coming in towards this guy and it's going to bounce right off. Or if it's on the bottom, it'll go towards in and it will bounce right off. This happens on the even multiplicity. Odd multiplicities have 2 cases. We have a multiplicity of 1 and we have any other odd number. For a multiplicity of 1, I call this a chop or a cut. You're at your 0 and it's going to cut through. You're at your 0, it's going to cut through. Those are your 2 options. It either cuts through going up or cuts through going down. If it is an odd that is not a 1, so 3, 5, 7, etc., it's going to create a little S going through it. So it's kind of like a smooth cut. Smooth cut. Or smooth chop. I don't know how you want to call it. Maybe an S if you want to write it as an S. So it would go down like this. So what I'm trying to say is I knew that this guy had to connect over here. So it connected. However, I'm looking at it, and this was x equals 5. That's what this one was. So maybe I really should have labeled these ones. So we have labeled these. We have the 5 right there. And 5 had an odd multiplicity for a 3. That creates the S shape coming down. So I really should have created more of an S shape going through the graph, and it goes through the graph like so. But again, I am following logic. Where does this have to go now? Well, it can't just go down forever because then I'd disappear off the video and not even go there. It must go back to this 0. So we're going to draw it back to this 0 right there. Once we get to that 0, we again look at the multiplicity. The multiplicity is 1. Oh, okay, so since the multiplicity is 1, look over here, that's a cut. It's going to go directly through. After that, again, we use logic. What has to happen next? It must go towards this -3. At -3, it has an even multiplicity. Even multiplicities are a bounce. So it's going to bounce off the axis. And what has to happen? These guys got to connect. And we're done. That's the entire question. It looks a little funky at first. It's like, where did this come from? Where did that come from? What's going on? It's actually not too bad, though. You're literally just playing a weird version of connect the dots, where your options, once you get to the next dot, are going to be bounce, cut, or S. Those are your only choices. Let's check out a few more examples so that we're not totally confused. So example number 2. We got g of x equals -1/2 x squared, x minus 3, x plus 7 squared. Okay. So on this guy, again, the first thing we got to do is we got to figure out that leading term. So we have a -1/2 x squared here. We have just an x coming from that guy. And then we have an x squared coming from the last one. So overall, this creates a leading term of -1/2 x to the 5th. In terms of our little picture, another way of doing it, instead of writing out the whole end behavior thing, writing as x goes to infinity, f of x goes to, as x increases without bound, what happens to y decreases without bound, what are we going to say instead? We're going to just say, oh, well, I know it's a negative odd, and negative odd looks like this, which means on the right-hand side it's going down, on the left-hand side it's going up. In fact, if it makes you happy, you can actually just start graphing right from there. And do the zeros in a little bit. So right away, I know on the right-hand side it goes down, so I am drawing arrows going down. On the left-hand side, I know it's going up, drawing arrows going up, boom, done. That's my end behavior. Now we got to identify the zeros. So we have zeros at x equals 0, at x equals 3, and at x equals -7. So those are my 3 zeros. And this one has a multiplicity of 2 because the exponent's 2. This one has a multiplicity of 1 because the exponent's 1. This one has a multiplicity of 2, the exponent's 2. Let's plot those guys down. So we have x equals 0, x equals 3, x equals -7. So -7, 3. And again, we are just using logic. Last time I started on the right and it went this way. This time I started on the left and going that way. It literally doesn't matter what you do. You're going to get the correct answer either way. So on this one, I'm following logic. What has to happen is I have to connect to this -7. Then at -7, I'm looking at it. What happens? Oh, at -7, it has an even multiplicity. An even multiplicity is going to be a bounce off of the axis. Now, a lot of students like to ask, how high does this go? Does it go all the way up to here? Does it go like down here? Does it go like this? Like, where does this top point go? Is it in the middle? Is it off to the side? Where is it? Where does this go? And the answer is, that is a great question to ask your calculus teacher, because you actually don't learn how to do that until you get to calculus. It is called a relative maximum or relative minimum, as is appropriate, and you have to do a fancy process called taking the derivative. And I would love to teach it to you. If you really want to end up learning, I can actually make a separate video on doing that. I love teaching calculus, but it is not part of this course. So in other words, you go however the heck high you want to, and then come back down. Another option, by the way, is going to be using an online graphing calculator, and I'll show you how to use Desmos if you'd like to, so you can do that yourself. Now, this one. If you notice, I started doing the bouncing thing early in advance here, and the reason why is because I knew at x equals 0, another even exponent, it's going to bounce off that axis. But likewise, at 3, it has a 1. A 1 is a straight chop, so it's going to chop right through, and it's going to connect. Technically, should it have a sharp edge like that? No, it should really be smooth and going down, but hey, you know what? Good enough for me. Now, you're in the middle of the quiz. You want to make sure that you got this right. What are you going to do? You're going to go to Desmos, because Desmos is your buddy, and you are allowed to use Desmos for your quiz. You cannot use your friends. You cannot use something else, but you are allowed to use Desmos, so let's use Desmos. Oh, hold on. This thing is telling me I messed some stuff up. Okay, hold on. Exit, Desmos. Yeah, it's another thing. Someone else is going to write in their next suggestion list. You should have Desmos open before you do this and have it set up so you don't look so silly. And you would be totally correct, because I don't even have it set up as a source on open broadcast software. Oh my gosh. I'm cut from the team, guys. All right, add Firefox. Okay, let's go. Okay, there it is. It is covering my face. That's fine. Okay, transition. Okay, there it is. Our function that we were graphing was g of x, we called it, was equal to -1/2. If you just type in the division sign, it immediately creates that fraction just like that. You'll need to scroll over to the right. X squared, scroll over, x minus 3, x plus 7. By the way, to get the squared up there, you have to hit the caret key, that's shift 6. Anyways, it creates this graph. Now, if I zoom out a little bit, now it's more like I made it. But if you notice how high that like on my graph, my graph did not go that high here. It's supposed to be like, if I was an accurate graph, this would be like way up there. But this is a sketch, and there's no axis over here. There's no label for how high this went. So good enough. This is happy enough for me. If you want to make it nice and pretty, you can, but I don't know, I'm messing around on this and just seeing it, and it goes all the way up to 164.513. So again, it's not actually at like 1.5 or anything like some people want to say. Oh yeah, I didn't transfer over, but it's at 164.513. Like some people want to say, oh yeah, it's got to be exactly between 0 and 1.5 and 3, so it's got to be at 1.5. It's not. You can use calculus to show it's at 2.135 or somewhere else. It's not important. You have this picture, you get full credit. Let's go on to the next page, or the next problem. Example number 3. And my example was written up here, but I had to close up Desmos. Okay, example 3. We got example 3. H of x equals 4 times x minus 2, x plus 5, x plus 1. All right, so this question's actually really, really easy. I gave this one here because it's the third example, and this would be the point in time in class where I'd be saying, hey, I'd like you guys to try one on your own, and this is a whiteboard practice problem. So this is a great time for you to actually like say, hey, did I actually get it? Did I actually do what I'm doing? So let's see if you can do it. Maybe pause, try out as much of it as you can on your own. All right, that was your shot. That was your opportunity. I'm going to go for it. So leading term, we have a 4, an x, an x, an x. That's going to be 4x cubed. That is this guy over here on our little chart. That means on the left-hand side it goes down, on the right-hand side it goes up. And we have 3 zeros. We have x equals 2, x equals -5, and x equals -1. And all of them have a multiplicity of 1. So that means every single one of them is going to be a cut. Some people get confused with this 4. They want to add an extra 0 about it. It doesn't have an x, and therefore it doesn't have a 0, and therefore it doesn't matter. It only takes a part for the leading term, and that is it. So creating my little graph up here. We need zeros at -1. -5 and 2, and my end behavior, it goes up on the right and it goes down on the left, and it cuts through every single one. So I'm just going to play connect the dots, and I'm going to cut through every single one. So cut, 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 yay, fast. That was really, it's really nice and easy when they're just all the same. Just boom, 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 done. Don't have to think about it. If you really wanted to, you could try to make your graph like more accurate or whatever. Like you can plug in 0, like you plug in 0 here, it turns out like this is like -20. You could like label stuff. I don't care. This is good enough. Put the x, put the f of x, 100%, because you have correctly gotten all of the You get that leading term, you got the end behavior, you got the zeros, and that's all I'm looking for. I want to make sure that you see this work. I don't want just the picture. I want to see the work along with it. I want to see those zeros. I want to see that you are understanding what's going on. One last example, because this one has fractions in it, and I know people hate fractions, so let's do that. Example number 4, and this one I'm making up on the fly because I realized I wanted to do it like when I started the video. So let's do m of x equals, and we're going to do, how about negative 2 times 3x minus 2 squared times 2x plus 1 squared. Okay. Easy enough. So steps are exactly the same as before, but you gotta kind of figure out what that leading term is. A little bit more obnoxious in this case, because we got negative 2 times 3x squared times 2x squared. That's negative 2 times 9x squared times 4x squared. That is negative 72x to the 4th. Oof. Using our chart from before, both of those guys go down. If you want to use the fancy terms, because we're trying to be fancy, we'd say, you know, as x approaches infinity, f of x approaches negative infinity, or as x decreases without bound, f of x decreases without bound. Don't need to say any of those things. We got 2 zeros to take care of, though. X equals, and our first one is going to be x equals positive 2 divided by 3. As a reminder, it is this guy over this guy. Change the sign. So the other one's going to be 1 over 2 with a negative in front. Those are the only 2 zeros on this question. And there we go. So let's go ahead and create our graph. So we got 2/3 and negative a half. So 2/3 might be like right there. You know, 2/3, and we got negative 1/2. Oh, I forgot to put dots there. Supposed to have dots. And then it needs to go down on both ends. So we're going down over, oh, you can even see, we're going down over here, and we're going down over here. That probably should have been more left, but whatever, it's still going to work because I'm playing connect the dots. But again, this is actually an easy question because I made them both have multiplicities of 2. Both of those guys have the same multiplicity, so they are both bounces. We're going to go ahead and bounce and bounce, and that's it. Probably shouldn't be that wide. It probably should be more, you know, straight down, but you know what? I'm happy with it. Full credit, in my opinion. Hopefully this wasn't the worst, guys. You have a homework assignment. So your homework assignment is going to be 4 of these on your own. And if you need help, I'm available on WebEx. I will post a video going over those 4 ones on Friday, but that is after the due date, so you do have to get them done on your own first. I will grade them, let you know how you did. That way I can tell you, hey, how much credit would you get on the quiz? Because you're supposed to take the quiz. The quiz is effectively assigned, you know, at Friday-ish, you know, Monday-ish, because, you know, you turn it in Thursday. You turn this homework in Thursday. Anyways, if you need more help, let me know. I will go over it. If you need help like in the middle of the quiz, you can actually ask me for help. I'm not going to go over that problem, but I'll go over a new example with you. I'll answer any questions you got. I want this to be, you know, not a stressful experience for you. If you end up needing help, even though it's like Good Friday and Easter and whatnot, I'm not going to be too busy. You just need to send me an email and be like, hey, Mr. Richards, are you available? Maybe I'll come by and help. Somebody in one of their forums said that they're not available until like 10 o'clock at night because they have to babysit and work and do all this other stuff. And you know what? Guess what? It's currently 11:49 p.m. and here I am making videos. So I can definitely just be helping you out instead. Let me know. Have a good one. Stay strong. I believe in you guys. Have a good one.